Hello and welcome to this video, which is a lab on packet sniffing. Okay, so as per the theoretical section, the first thing we want to do with packet sniffing is initiate a man-in-the-middle attack so that all the traffic from this victim machine, this Windows 10 victim machine, is routed through our Kali attacker machine before it gets to the gateway. So in other words, we're going to put this Kali machine in the middle of traffic destined for the gateway from this machine and vice versa. Okay, so how do we do that? Well, these are the commands. So as you can see, it's ARP and some ARP spoofing. So we're going to do some ARP spoofing to put ourselves in the middle. So let's just quickly take a look at a few things. Okay, so the first thing I want to do is just do a look at the current ARP table. So you do ARP space -a. Okay, so this on the Kali machine only has one entry in the ARP table, and that is for the default gateway, which is 192.168.1.1, and that is the MAC address of the default gateway. Okay, so if I go to the victim machine, this Windows 10 machine, and say ARP -a, you can see that there is the default gateway as well, and as you can see, it's got exactly the same MAC address, F80113 ending in A2, exactly the same as that one. Alright, so now we're going to start the spoofing. So the first thing we need to do is type ARP spoof -I and then the network interface -T and then the target IP address. Okay, so let's just quickly do that. So if I do an IP config here, this one's IP is 1.100. Okay, so -T, so it's 192.168.1.100, and literally just, and then the default gateway, 192.168.1.1. Okay, so now it is starting an ARP relay spoofing attack. Now we need to do exactly the same in reverse. In other words, we just need to swap the IPs. We put the default gateway here and then the target there. So let's just do that quickly in another window. So it is, once again, ARP spoof -I Ethernet 0 -T, this time gateway first, 192.168.1, and our target 192.168.1.100. Great. Okay, so now the spoofing attack is underway. So what I just want to do now is just quickly scroll up here so that you can see that was the original MAC address of the default gateway. And if I do an ARP -a, you can see that it's changed. In fact, it's got exactly the same MAC address as this 54. But the user would not be aware of this unless they're taking constant view of the ARP table. And as you can see, it's set to dynamic, and that is why we are able to do this. So that's pretty much it. We are now right in the middle of all traffic headed between this Windows machine and the default gateway, and vice versa. So let's just minimize that, and let's take a look at driftnet quickly, which is quite a nice tool to illustrate the power of a man-in-the-middle attack. Okay, so let's quickly take a look at driftnet. You can start driftnet from this menu here. So as you can see, there's a whole bunch of tools for sniffing. So there's driftnet, and we'll be looking at Wireshark. But as you can see, ARP spoof's not in the menu, but it's really a really great way to initiate a man-in-the-middle attack once you're on a network. Alright, so let's kick driftnet off. We'll just click the link for now, but you can also call it from the command line. And if you look at driftnet, it gives you a whole bunch of settings that you can add, but the only one we really need is the interface file. I mean, you can go through all these in your own time and look at them, but just to illustrate man-in-the-middle, let's just do a driftnet -I and the interface. Okay, and then as soon as you hit enter, you get this little driftnet window. So let's just quickly see what happens. I've tried to go to google.com, and strangely enough, I can't get there, even though my Windows machine says it has internet access, and there's a reason for that. So let's just close driftnet. The main reason is that we are supposed to enable IP forwarding. That's actually a very important thing to do. Otherwise, your user's not going to be able to connect to the internet, because all traffic is literally ending at your machine, and their packets are not being forwarded back. So what you need to do is open another terminal window, and you literally go to this setting file, which is located in the proc directory. So let's just quickly cat it. So it's cat /proc /sys /net /IPv4 /IP_forward. Great. So as you can see, the setting is 0, which means IP forwarding is set to off. So the way to fix that is to literally just change that 0 to a 1. So we go sudo nano /proc /sys /net /IPv4 /IP_forward. Great. Now I'm in that text file. Literally going to just change that to a 1, delete the 0, Control X to exit, Shift Y to save, and it's done. So if I run that cat command again, I now have a 1 running. Okay, so let's try driftnet again. So it's driftnet -i eth0. So it's very important to do that, otherwise you're going to actually initiate not a man-in-the-middle attack with a denial of service, which sort of gives the game away. Okay, so if I do driftnet -i eth0 again, it'll bring up our little window, and let's see what happens if I go to google.com now. Great. As you can see, Google is now working, and we now have internet access. Let's start the man-in-the-middle sniffing. Alright, so what driftnet does is it pretty much captures images from the target machine as it flows through towards the gateway. So let's just quickly go to a site that's got a lot of images. Let's try cnn.com and see what happens there. As you can see, CNN's loading for the user, and we're starting to get some traffic, and there we go. Now all the images on CNN are pretty much starting to come through on driftnet. You can see a few images there, and if you give it enough time, pretty much all the images are going to come through to driftnet, which is quite interesting. So for example, if we go to another site, let's try Apple. In theory, all the images will come through. So if you look at, while we wait for Apple to load, if we look at this, you'll see that driftnet actually starts looking and gives you some feedback. So a lot of the times it says the image's data is too small to bother with, and that's probably why a lot of the stuff isn't rendering. But I mean, here's the Apple site. I haven't seen anything come through yet. So let's go let's click on a few pictures. And see if that brings any driftnet. So as you can see, it's reading traffic, but let's see if anything actually came through to our driftnet window. As you can see, there is some Apple devices, there's a whole bunch of other stuff in there. So as you can see, driftnet is quite an interesting tool. It's really a good tool to just illustrate how packet capturing is working, because I'm actually seeing, as the attacker, images that the victim is looking at on their computer. Alright, so let's leave driftnet there and move on to something a little more practical. Alright, welcome back. Let's look at a tool called Wireshark, which is probably the de facto standard of packet sniffing software out there. You can start it by typing Wireshark at the command prompt. It'll give you an error, pretty much telling you that you shouldn't run it as root, but we'll just ignore that. And what I usually do is just choose the interface you want to listen on. So our interface here is ETH0. So if I do that, you should start seeing traffic flowing, because this is quite a busy network. So Windows is always trying to connect to something, and you can see the TCP and the redirects, and that's what those packets are. So just a quick thing about Wireshark. Wireshark is a massive tool, and it takes a lot of practice to actually get to it. It's actually very overwhelming when you start because it's throwing so much data at you all the time. I mean, it's already collected 180 packets, as you can see, and we haven't even started doing anything. So let's see if I click on this like iPhone thing here. It should start throwing a whole bunch of more traffic through. As you can see, it's really starting to throw things around. So what I want to do now is actually show you how to do a little bit of filtering on Wireshark. Let's just close that so that it gives us a little bit of a break, and close that one as well. Great. Okay, so let's just stop the capturing right there. Okay, so we've captured 2,930 packets, as you can see. But going through all of these is going to become a small nightmare because there's so many of them. So what you need to do with Wireshark is actually use filters. So there's a whole bunch of filters. You can literally click the expression thing and it'll tell you a whole bunch of stuff there. But the ones that you actually want to use are just the protocol. So let's look at all HTTP traffic. So all you do is type HTTP. Okay, there's all the HTTP traffic that's floating through. If you want to look at ARP traffic, same thing. You say ARP, and it'll give you all the ARP traffic. If you want to see traffic related to one machine only, so this one's 192.168.1.100, you do IP.address. You see it even gives you a whole bunch of examples. .addr equals 192.168.1.100, and there is all your 1.100 traffic, which is obviously the busiest one because that's the one we're sniffing. Alright, so let's just clear this and let's go see if we can get some password sniffing done. Alright, so I'm going to start a new captcha and ES0 and start. Okay, and we pretty much filtering on 192.168.1.100. Okay, so let's just open up a browser. Let's go to a website, one that I've specially prepared for this demo, and then I'm going to, as a user, just log in as an admin. See if I can get into this thing. So I'm just going to put in a bogus username and password, admin and password 123. Okay, so that's done. So now let's see what we've done. So as you can see, it's been capturing traffic all along the way. So now what I want to do is filter on HTTP only. And if I go through my HTTP traffic, I can see there's a post request here. So if I move this middle section up slightly, and in this HTML form URL encoded section, you can see it's literally sniffed the username. In this case, it's the log is equal to admin, and the password I typed in was password 123. So as you can see, sending text or sending a username and password over clear text is very easy to sniff if you have initiated a man-in-the-middle attack. And that pretty much covers a very quick demo on Wireshark. As I said before, it's a very large tool, so you can do a lot with it. And I'll see you in the next video.